In the dark voids of the solar system, drifting in between the familiar planets and their families of moons, are the asteroids. There may be 1 million, perhaps 2 million of these cold, dark rocks, but these small worlds are anything but dull. In fact, some of them are time capsules from the very beginning of the solar system, unaltered for billions of years, and the clues to how everything around us began, from the formation of the planets to the beginning of life itself, may be locked up in these asteroids. And tonight, a spacecraft from Earth is going to touch one, bring back a sample, and prepare for the long journey back to Earth so we can analyze it.
OSIRIS-REx has descended below the 5-meter mark. The hazard map is go for tag. Contact expected in 50 seconds.
We're going in. We're going in.
OSIRIS-REx is a one-of-a-kind spacecraft with an extraordinary team of engineers and scientists charting unexplored places. It was launched on September 8, 2016. The vehicle has traveled over 2.2 billion miles on a complex route to reach Bennu. You are here with us on a historic evening. It'll be NASA's first sample return from an asteroid, the attempt to actually sample the asteroid Bennu.
This is a reality. We're actually going to be trying to sample on an asteroid.
This represents the hopes and dreams, hard work, blood, sweat, and tears of thousands and thousands of people who have worked on this program for over a decade to make this a reality. The mission is dedicated to my friend and my mentor, Dr. Michael Drake. Mike passed away just 4 months after we were selected by NASA to lead this mission. And, he left some parting words. And he said, first of all, you can do this. You've got the team. We're one team. These are big questions. Everybody's rooting for you. Everybody's behind you. And we can take that and lead them forward.
It's just amazing. We've been rehearsing this event, all the different mission calls and milestones, but then to actually be here tonight and realize that this is going on 200 million miles away.
That's right, yeah. I'm pretty excited. 3, 2, 1. And liftoff, OSIRIS-REx.
The pandemic has changed the way we lived our lives. Masks and social distancing have become a way of life.
As the whole world was coming to grips with the pandemic in the March timeframe, this team was in the midst of preparing for the checkpoint rehearsal that would take the spacecraft only 65 meters above the surface. So we had to rethink the entire way in which we were going to do that rehearsal with only a skeleton crew here in the building and with many of our team members remote.
I think the hardest phase of the mission was in spring of 2020 when the COVID pandemic hit. It was a scary time and we were exhausted. And I would say probably by April, about a month after the lockdown, I wasn't sure we were going to be able to do it. And it wasn't because of the technical challenges, but it was the stress and the human factors that I was really starting to worry about.
Now the main event is happening in about an hour. This is called TAG. Can you explain to us a bit why it's called TAG?
Yeah, today we're tagging an asteroid, and TAG is an acronym that describes our sample collection strategy.
We're going to send the spacecraft down for a short duration contact with the asteroid surface, anywhere between 5 and maybe as long as 15 seconds. So we call it a touch and go, or tag an asteroid.
And that sample site we're going for today, Nightingale, it's just a few meters in width. Just take a step back for a second and put yourself in the shoes of some of those engineers on this mission. And imagine trying to park a spacecraft on an asteroid 200 million miles away, in a space no larger than a few parking spots. As if parallel parking on an asteroid isn't hard enough, imagine also trying to dodge hazards like rocky boulders as you're making your descent down to collect a sample. And on top of that, the team has actually programmed the spacecraft to steer itself down to the surface.
We mapped the surface of Bennu to unprecedented resolution of 2 centimeters per pixel, which is better than what we've done on our own Earth and Moon. So it was a huge Herculean effort to get to this point where we're comfortable handing the maps and the keys over to the spacecraft to get us down into this small site today.
So right behind me is the MSA, the Mission Support Area for OSIRIS-REx. And today it is filled with very excited people, the scientists, engineers, and technical specialists who've worked on this mission, in some cases for more than a decade. So back there is Gary Napier from Lockheed Martin. He's right in the middle of it all. So Gary, what's the feeling in the room?
Michelle, like you said, I am just right behind you, about 20 feet. We're here in the larger Lockheed Martin Mission Support Area, where we're operating 6 of NASA's spacecraft around the solar system, 4 of them at Mars, 1 of them at Jupiter, and this one right here, OSIRIS-REx.
So it's important to understand that the spacecraft is actually literally on the other side of the solar system, over 200 million miles away from the Earth. So any signal that we were to transmit here would take over 18.5 minutes to reach the spacecraft. So when we get these signals back, we're actually seeing things that happened in the past at the asteroid. Earlier we departed our orbit around the asteroid, so we're flying over the sunlit side of the asteroid, taking images for the onboard guidance system called natural feature tracking. A couple other key events that have taken place already is the spacecraft has deployed its robotic TAG-SAM sampling arm, so the arm is ready, in position to collect that sample. And we've turned on and started collecting science data from one of our science instruments, the OTIS thermal emission spectrometer. The spacecraft has already moved into its second natural feature tracking attitude and is getting onboard positional updates as we speak. And I can tell you everything is going exactly according to plan right now. It looks really good.
Now, remember that this is a historic event. Today's endeavor will be the first time the space agency has ever touched the surface of an asteroid, collecting a sample of this pristine ancient material, a scientific treasure far more precious than gold. Let's talk a bit about why working in this low-gravity environment makes it tough to get a sample, because you might think sort of at first you could just take like a robotic claw or a robotic arm and scoop something up, but that's not going to work in these conditions.
That's exactly right. The microgravity of Bennu provides a challenge of sampling that we don't normally face on Earth. You can imagine trying to use a shovel or a scoop on Earth, and the ground pushes against you, but the gravity keeps you on the ground. On Bennu, the surface gravity is thousands of times lower than on Earth, so if you pushed a shovel or a scoop into the ground, you'd push yourself right off the surface. So we had to come up with a technique that worked in the microgravity environment and that could work in this tag architecture, this touch and go architecture of just a few seconds long.
So I understand the next big milestone we're looking for here is something called match point.
That's right.
So what happens at match point?
Match point is the final maneuver that the spacecraft performs by firing its thrusters. That's where we become centered over the Nightingale sample site and begin that final descent down to the asteroid surface. And the spacecraft is solely focused on its safety calculation and the decision on whether or not it's going to proceed down to collect that sample.
Attitude control system has transitioned to touch and go mode.
Right, spacecraft's getting ready to make contact with the asteroid surface here.
OREX MSA on OREX off. OREX is descending below 25 meters.
Okay, we're getting really close. And I want to remind you, it's the 5-meter crossing that's the really critical one. We're only a couple minutes away from that. So the spacecraft has one key decision left to make. It's calculating right now the probability that it's going to come down either on a hazardous area, as we defined on that hazard map, or in a safe area. So we may, at 5 meters, the spacecraft may decide that it's hazardous and it's going to back away, allowing us to live to tag another day. So to me, all my senses are on that call out right now.
Yeah.
I really want to hear that we are go for tag.
Position uncertainty is 0.5 meters. Predicted tag lateral offset is 1.7 meters. Hazard probability is 0%. Tag lateral velocity is 0.2 millimeters per second.
Oh my God.
Tag vertical velocity is 10.2 centimeters per second.
That sounded really good.
Yes.
So it sounds like the hazard map calculation looks really good. We're coming down on a green area.
MSA on OREX off. OREX has descended below the 5 meter mark. The hazard map is go for tag. Contact expected in 50 seconds.
We're going in. We're going in.
Touchdown to tag. Sampling is in progress.
Oh my gosh, we're there, folks. That was amazing. I mean, I don't know if you saw the team here, but they just kind of blew up. It went from being steely-eyed to like celebrating the Super Bowl. Congratulations. How you guys feeling?
Transcendental. I mean, I can't believe we actually pulled this off.
OREX MSA on OREX op. Sample collection is complete and the back away burn has executed.
All right. The pyro bottle's fired, so tag SAM operated. The back away thruster's fired, so we're safely moving away from the asteroid surface. The spacecraft did everything it was supposed to do. We did it. We tagged the surface of the asteroid, and it's up to Bennu now to see how the event went. It's almost hard to process everything that's happening right now. It's overwhelming pride in this team and everything we've done to get here. I couldn't really have anything better to say about this group of people.
We are here live after some excellent news. I'm here with an exultant Dante Lauretta from the University of Arizona. So one more time for our audience out there, explain when we know we'll have a sample.
A little overwhelmed right now, Michelle, I have to say. It's been pretty intense several minutes here. I can tell you that everything went just exactly perfect, which is kind of the hallmark of this team. We have consistently beaten expectations over and over again. We have overcome the amazing challenges that this asteroid has thrown at us, and the spacecraft appears to have operated flawlessly. We don't know how long we were in contact with yet. That's some reconstructed information that we're going to have to put together over the next few hours as the data come in. We backed away successfully from the asteroid surface. The team is exuberant back there. Emotions are high. Everybody is really proud. We have some work to do to determine how much sample that we have collected. The next thing that I'm going to be looking for is once the spacecraft cools off, it probably got pretty warm as it approached the asteroid surface, so it needs to get rid of some of that excess heat. It's got to get those solar rays back onto the sun and get power positive. Once it's stabilized, it's going to point that high gain antenna at the Earth, and we're going to start bringing that data back. And those SAM-CAM images are going to tell us an enormous amount of information about how the events of today went.
It's going to be a long, hopefully happy night for all of you as more data comes in. Thank you so much. It's been such an honor to be with you.
Thank you. Thank you, everybody, for a great evening, and kudos to this team. It's an amazing experience.
Oh, wow.
And history was made tonight.
Hello, everyone. I'm Nancy Neal Jones from the Office of Communications at NASA Goddard Space Flight Center. Yesterday, NASA's first asteroid sample return mission, OSIRIS-REx, successfully made contact with the surface of asteroid Bennu to collect a pristine sample for delivery to Earth in 2023. To share some remarks with us and to tell us more about what happened yesterday and what's coming up for the mission, we have with us today Dante Lauretta, OSIRIS-REx Principal Investigator, University of Arizona.
So yesterday was all about monitoring this real-time telemetry from the spacecraft as we watched the events unfold 200 million miles away. And the question that came up over and over again in that live broadcast was, when are we going to get the images back? When are we going to know how the sampling event went? I can tell you, a lot of us were up really late last night. We were watching the images come down one by one. By about 2 a.m. here, local time in Denver, we got what I call the money shot, where we saw TAG SAM contacting the surface, and then the effect of injecting that high purity gas down into the asteroid regolith. I must have watched it about 100 times last night before I finally got a little bit of shut-eye, and then I dreamed of a wonder world of Bennu regolith particles floating all around me. Well, like everything on Bennu, a nightingale was unexpected in the way it behaved to the contact from the spacecraft. It's fun to go back and look at some of our early animations where you can see the TAG SAM head pushing firmly onto the surface, kind of like hitting a pad of concrete. There's a little bit of grain and dust that gets kicked up. And you know, we didn't make that up. We tested TAG SAM dozens of times, including in microgravity on NASA's C-9B microgravity testing aircraft. And that's what it looked like. TAG SAM pushed down onto the regolith bed, a few little particles floated away, kind of like coins flipping in slow motion. You could hear the rumble as the gravel got ingested into the TAG SAM head, and then when you pulled away, there was a tiny little divot underneath what TAG SAM had excavated. And we really thought Bennu was going to behave just like the test chambers did. But no, it was completely different. There was almost no resistance whatsoever from the asteroid's surface. The TAG SAM plunged in. It was like dropping into a pool of water. And we were deep into the asteroid subsurface even before that gas fired, and we just kept going. If we hadn't fired the back-away thrusters, we think the spacecraft would have just disappeared like into a pool of quicksand. So as a result of that really soft, compliant surface, the gas from TAG SAM and the thruster plumes from the back-away burn excavated an enormous crater, 8 meters or about 25 feet in diameter, way bigger than anything we expected. Our glorious moment, we safely contacted the asteroid surface, bury the tag SAM head and fire the gas, and you will load that thing up. Turns out we did too good of a job. So, we backed away. 2 days later, on October 22nd of 2020, we put tag SAM through a photo shoot. All kinds of different camera angles and lighting conditions, just trying to get some hint, was there any sample that was collected in this amazing event? It looked like the tag SAM head was literally spewing material into outer space, and panic shot through me at that moment. And I was like, oh man, we're bleeding. We're losing sample at an enormous rate. About 10 grams were visible in that one shot. That was, 1/6 of our total mission requirement in a few seconds that we were seeing escaping from the tag SAM head. The good news was, the reason we were leaking material was because we had collected so many large stones that we were jamming open the safety valve meant to keep everything inside the collection chamber. So we got permission from the agency to go through rapid stow, quickly got the tag SAM head into the sample return capsule. Through some very clever mathematics, it looks like we collected about 250 grams or about 8 ounces of material. 4 times the mission requirement is what we expect is in that sample return capsule today. And fortunately, we were able to go back to Bennu in April of 2021 to get some great imagery and spectral data of the surface to really quantify the nature of that disturbance. When we designed the mission, we did not plan to go back and image the tag site after sample collection. We thought this is such a risky maneuver, get the goods and get out of Dodge kind of approach. But after that amazing and dynamic response of the asteroid surface, I couldn't leave it alone, right? I was like, this just keeps bothering me. We have to understand what we did, and we have to document it for science and for future asteroid explorers to understand why this behaves so differently. When we estimate the strength of the particles that we see on the surface, there's no way they would survive passage through Earth's atmosphere. They would simply disintegrate, forming a giant fireball. So I have high confidence that we're bringing back the kinds of material that literally, physically cannot make it to the surface of the Earth as a meteorite.
All stations, the ADM burn is completed. We have a nominal ADM burn, and we're bringing the samples home.
Really surreal when you're talking about an asteroid sample return mission, 13 years ago, that we'd actually be at this point now. I had every confidence in the team that we get there, but your mind just isn't going there, right? You're just trying to get to launch, then you're just trying to get to the asteroid, then you're just trying to get through proximity operations and collect the sample. So you're taking a day at a time getting through operations. But yeah, now that we're here, ready to release the capsule, ready to finally collect it, culmination of all this work, decades of work, from thousands and thousands of people on the team. It's just an incredible sense of accomplishment, and really excited to see this thing get on the ground.
All we have left to do to deliver on our promise to the agency is get that sample safely back to the Earth, get it into our laboratories, and answer the fundamental questions about the formation of our solar system and why Earth is a habitable world.